Hello, I am going to review the answers for the review of quiz number 5. Problem 1 states the following. A person wishes to watch a movie on a streaming service. She has 3 different devices that she can use to watch the movie. Also, she has 4 different streaming services to choose from, and each streaming service has 5 different movies that she can watch. How many different ways can she choose to watch a movie? Well, in this example, we apply what's called the fundamental counting rule. We take the number of options for her devices, that's 3, times the number of streaming services she subscribes to, that's 4, times the number of movies she desires to watch. Multiply out these options to get 60. Number 2 states the following. 10 people are lining up at a checkout counter in a market to pay for their items. How many different ways can the people line up? Well, anytime we have a line being formed and we're trying to arrange all the people in the line, we can use permutation rule number 1. That's 10 factorial, which computes to 3,628,800. There's a second part to the problem, and now states how many ways can 4 of the people line up if they are chosen from the original 10 and transferred to form a new line at a different register. So now we're selecting 4 people from the 10 and looking at all the ways that the 4 people can line up. This is permutation rule number 3. When we select without replacement a portion of a group of objects, in this case people who are forming a line in a store. So we have 10 people, we're choosing 4 and we're permuting all 4. That's going to compute to 5,040. In number 3, we have another type of problem here. It says a real estate firm employs 10 female agents and 5 male agents. If a group of 4 agents are to be selected to show properties that the firm is listing on a particular day, then answer the following questions. A group of any gender is formed. So in this situation, we just count all 15 agents and we are selecting, I think we wanted 5 agents. Actually, we wanted 4. So this is 15 C4. Let's calculate that. And you can use your calculator or Excel to perform the computation. So 15 C4 is actually 1,365. Okay, because we want a group of 4. So remember, combinations, we're counting groups. Anytime you have a committee or a group, you're dealing with combinations. Order is not important. For part B, it says the group must have 3 men. So what this means is we have to divide our combination rule into different categories. We're going to have men. There are 5 men. We choose 3 times. Remember, it's a group of 4, so if we have 3 men, we still need 1 woman to be on the group. So there's 10 women, and we choose 1. 5 choose 3 is 10. 10 choose 1 is also 10. So in this scenario, there's 100 different groups that can be formed. And then finally, for part C, it says the group must have at least 3 women. At least 3 women means 3 or more women. So remember, the group is a group of 4. So we have to either have 3 women or 4 women. We find the total number of combinations for each of these situations and then add the results. So for 3 women, well, we have 10 women, we choose 3. That means we still need 1 man to be in the group. So 5 choose 1 man to be in the group. 5 choose 1 is 5. 10 choose 3 is 120. 5 times 120 is 600. So that covers all the different groups for containing 3 women. Now we look at all the groups that contain 4 women. Now, if we're choosing 4 women, that means that there's no men in the group because it's a group of 4. So we have 5 choose 0 men, and then 10 choose 4 women. 5 choose 0 is 1. 10 choose 4 is 120. And we multiply, so that's going to give us 120. And then we now have to go ahead and add, it's actually 210. I think this is a typo here, so that should be 210, sorry. So there's 210. I just recalculated it. So 10C4 is 210. 1 times 210 is 210. We add these two numbers together to get the final answer. 600 plus 210 is 810. So there are 810 different groups that contain at least 3 women. Number 4 states the following. It says, how many ways can the letters of the word parallelogram be arranged? In this scenario, we're counting the number of permutations and then dividing out all repetitions of each item. So altogether, there are 13 letters. So in the numerator, we have 13 factorial divided by the number of repetitions for P, that's 1 factorial, times the number of repetitions for A, so 1, 2, 3, 3 factorial, times the number of repetitions for R, that's 1 and 2 factorial, times the number of repetitions for L, there's 3, so 3 factorial. And then for all the other letters, there's just 1 factorial each. If we calculate the denominator, we're going to get 72. 13 factorial divided by 72 results in the answer. It's 86,486,400. Moving on to number 5, it says the following. A person can use uppercase letters, lowercase letters, and digits to form a code word with 4 characters. How many such code words are possible if repetitions are allowed? So first of all, let's think about this. We have 26 uppercase letters plus 26 lowercase letters plus 10 digits. So if we were to add all of those numbers together, we end up with 62 different possibilities for each character. So if the code word is allowed repetitions, that means we have 62 choices for each different character. And so 62 times itself 4 times is 14,776,336. The second part is saying that the repetitions are not allowed. So we start with the first character. There's still 62 options, but one of these 62 characters is assigned to that position. So now we only have 61 options for the next position, and then it's going to count down in a similar manner for the other 2 positions. We multiply this out to get 13,388,280 different code words that are possible. Finally, we have this other problem which involves the computation of permutations, and we still will use the counting rules to compute these probabilities. So number 6 says the following. A person wishes to purchase 3 puppies from a pet shop. The pet shop is selling 6 French Bulldog puppies, 8 Chihuahua puppies, 8 Jack Russell Terrier puppies, 2 Maltese Shih Tzu puppies, 4 Pug puppies, and 7 Pomeranian puppies. Compute the following. So remember, we're now computing a probability using combinations. So when we perform the computation, first we take care of our denominator. Altogether, there are 35 puppies, and we're choosing 3. So the denominator covers all possible selections. In the numerator is where we get more specific, right? We want 3 pugs. Well, how many pugs are there? There's 4 to choose from, so it's 4C3. 4 choose 3. Performing our computations, that's 4 out of 6,545, which we can represent as a decimal as 0.000611. Part B says she purchases 1 French Bulldog puppy, 1 Pomeranian puppy, and 1 pug. Well, once again, our denominator does not change. It's 35 puppies, choose 3. Now for the French Bulldog puppies, there are 6. So we have 6 to choose from, and we choose 1. For the Pomeranian puppies, there are 7 to choose from. We choose 1. And finally, for the pug puppies, there are 4 to choose, and we choose 1. So when we calculate those combinations, we get 6 times 7 times 4, which is 168 divided by 6,545, and that's going to give us 0 and 257 10,000ths. For part C, it states she purchases at least 2 Jack Russell Terrier puppies. So first, we have to calculate the probability that she purchases 2 Jack Russells. Well, there are 8 Jack Russells to choose from, so 8C choose 2 times the other dog can be any of the other types. So collectively, there are 27 other dogs, and we choose 1 of them. The denominator remains the same, 35 choose 3. 8 choose 2 is 28. 27 choose 1 is 27. 35 choose 3 is 6,545. We end up with 756 divided by 6,545, which is 0 and 116 thousandths. So that covers the case for 2 Jack Russells. And now we look at 3 Jack Russells, because remember, we want at least 2. So in this scenario, all the puppies are Jack Russells. So there's 8 to choose from. We choose 3. That means from the other dogs, there's 27 other dog types. We're choosing 0. That's divided by 35, choose 3. We end up with 56 times 1, which is 56 over 6,545. And that is 0 and 9 thousandths. Finally, we add these 2 probabilities together, and we end up with 0 and 125 thousandths. And then D states she purchases 2 Maltese Shih Tzus and 1 French Bulldog. While there are 2 of these Maltese Shih Tzus, we choose both of them, so 2 choose 2. There are 6 French Bulldogs, we choose 1 out of the same denominator, 35 choose 3. 2 choose 2 is 1, 6 choose 1 is 6. 6 times 1 is 6, divided by 6,545 leaves us with 0.000917. Thanks for watching the video. Good luck on the quiz.